All right, day 15, writing equations of hyperbolas. If you know how to write the equation for an ellipse, then writing the equation for a hyperbola is going to be pretty much just the same thing. You're going to be given the focal point, and then you'll be given some other information, and you'll have to find out what A and B is from that information. But it's very, very similar to what we did for the ellipse. This doesn't change. To write in standard form, you still have to know the center, and you need to know A and B, because then we can get A squared and B squared. Remember from the ellipse, the A value told us our vertices. That was the distance from the center to our vertices. It's the same thing for a hyperbola. And then it also deals with the transverse axis, which remember we talked about was similar to your major axis for an ellipse. The B value deals with the conjugate axis. Our C value still deals with our focal points, the distance from the center to our focal points. This is a little bit of a change. When we did ellipses, we had C squared equals A squared minus B squared. Well, now you'll notice that we're doing A squared plus B squared. And that's basically your Pythagorean theorem. So let's take a look at an example here for hyperbolas. And then I'll probably do another example in class tomorrow, and you guys can get going. Don't forget, you do have a quiz tomorrow. Make sure you know how to graph circles, parabolas, ellipses, and know how to write the equations for circles, parabola, and ellipse. For the circles, make sure you know how to write an equation if I give you the center and a point on the circle, which means you got to use your distance formula. So just a little tip there for you. All right, so let's take a look at this first problem here. We're going to do it basically exactly like we've been doing for the ellipse. Write the equation. You're given the focal points, and you're given the length of the transverse axis. So the length of the transverse axis is 8, and what we know is the transverse axis deals with my A value. Now, if you'll recall, the transverse axis is actually 2 times A. So if I know that its length is 8, then I know that my A value is equal to 4. So I already know A right off the bat. And now I'm going to use my focal points to find C and to find my center. So let's just start out and go through the steps that we've been doing when we work these problems. First of all, let's find the center. And the way we do that is we find the midpoint. So -3 minus 3 over 2 and -7 plus 3 over 2. And so let's see, that's -6 over 2, which is going to be -3. And that is -4 over 2, which is -2. So there's my center right there, -3, -2. All right, so now I'm going to plot that. So what I'm going to do now is I'm going to find C. And to find C, I'm actually going to plot my points here. Let's see what we've got when we plot this out. Let's see here. Let's go right here with it. All right, so let's plot these out and find out what we're doing here. Go down a little bit more there. All right, so let's see here. So let's see, my focal points, -3, -7. That's going to be here, and -3, +3. That's going to be there, and then my center is at -3, -2. There's the center. Now, this distance here from here to here, that should be my C value, and it should be the same distance as here to here. So let's see, we go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So it looks like that my C value is 5 here. So I now have my A value and my C value and my center. So the next thing I'm going to do is I'm going to go and find B, because I need to know B in order to write my equation. So what I know is that C squared is equal to A squared plus B squared. So C squared in this case is 25. A squared is 16. So subtract 16. We get 9 equals B squared, which is really what I need. But if you wanted to go one step further just to get B, you could do that here. And now I've got B, I've got A up here, and I've got my center, so I can write my equation. Now remember, when we write the equations, we have to be careful, because we need to know whether it's a vertical or a horizontal hyperbola. If you look at the way we counted here for the focal points, we counted vertically. All right, so that means that we have a vertical hyperbola, and that means that my A value I would also count vertical for. Now, we didn't actually count vertical for the A values here. I mean, if I did, 1, 2, 3, 4, that would be one vertice, and 4 down, that would be the other vertice. So I know my hyperbola is going somewhere, along here. All right, so I do have a vertical, which means that this A value, or A squared, has to go underneath the Y. Has to go underneath the Y expression. So remember, for hyperbolas, A squared always comes first. So what we're going to do here, we know that when we're doing a hyperbola, we know that we got to have a minus, and we know that A squared comes first and that B squared comes second. Remember, it's not the larger number for a hyperbola. So since it is vertical, we're going to put our Y expression on top here. So we're going opposite of K, so Y plus 2 squared, and then opposite of H there, X plus 3 squared, and that is the equation of our hyperbola. Very similar to the ellipse, okay? Since it is vertical, we're still putting A squared under Y. You just have to make sure you put it first because of the minus there. So tomorrow I'll do another example of one of these that will be horizontal, but that gives you a good idea of where we're going for ellipses.